So in this video, or in the last videos, we dealt with truth tables that had only two components, P and Q. In this one, we're going to introduce a third component and see how it changes. So P was the boy does his homework. Q is his mom gives him ice cream. Let's make R, let's see, red, I'll make it green. R is his mom gives him candy. And of course the negation would be his mom does not give him candy. Alright, so we'll put this off to the side actually. We need to finish not R. Add this to our arsenal of knowledge. Okay, so let's evaluate the statement. I'm going to put this up here so we have a little bit more room to work with. There. All right, so P or Q and R. Let's draw that a little neater. P or Q and R. All right, so some of these we'll be able to steal from our cheat sheet up here, but we're gonna have to work this out. And unlike our first truth tables where we only had 4 rows, this one is going to have more than that. And the way we know how many rows it is we take the number of variables and we start with a number which is the number of outcomes that each variable could have. So it's either true or false, and that's 2. So we start with the number 2, and then we raise it to the power of the number of variables. So there's 1, 2, 3. So we raise 2 to the 3. No. So 2 to the 3, when we have 3 variables, is 2 times 2 is 4 times 2 is 16. We're going to have 16 rows. Now if we, consider the other problems, P and Q, that's 1, 2, 2 to the 2, it's only 4 rows. So we're going to need a lot of room when we evaluate this one. So let's make some room. And I guess we should just get started. All right, so actually I'm going to scroll down a little bit. So we have P, Q, and R. So if we need 16 rows, is that right? No, it's 4. 2 times 2 is equal to 4, and 4 times 2 is equal to 8. That makes sense. All right, so true, 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 false, 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 false. True, true, false, false. You see how systematic this is. True, true, false, false. And then on the last one, true, false, true, false, true, false, true, false. Now, so we're going to evaluate first what's inside the parentheses, P and Q, or Q and R. So Q and R is these guys. True and true is true. True and false. True and false is false. False and true is false. False and false is false. True and true is true, but the next 3, unless they're true and true, they're going to be false, so that the rest of them are all false. And now we know what P is, because that's just given to us in our assumptions, so we can just copy and paste that. And now we're going to compare we're going to compare P, or, Q, and R. These two tables that we've already written out. So true or true, that's just going to be true. True or false. Anything that has a true in it is going to be true. So we can just look for T's. And now we notice the bottom three are all F's. So the top 5 are trues, the bottom 3 are falses. And what we were asked to do, which I failed to draw out, but I'll do that now, is prove that that is equivalent to P or Q and P or R. Because if you see, this is a simple step. We use the distributive property of P and Q or P and R. I'm sorry, P or Q and P or R. P or Q and P or R. That's how we got from here to here. But we're going to use this truth table to show how they're equivalent. So let's P and Q. P and Q is, we'll do that in blue. P and Q. True, true is true. Anything with a true in it is going to be true. So we're just going to look for anything with double falses. We see the bottom two are both false. So we can just write false, false, and then true it up the rest of the way. That's right. 6 plus 2 is 8. And then P or R. Do that in purple. P or R. Again, we're looking for anything that has double falses, and that will be our only false instance. So we have a double false here, double false here. It appears to be only 2 of them. False, false, false. Okay, so it's going to be false, true, and false at the bottom. And then the rest of these, there's a true, 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 true all the way up. True, 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 true. All right, now we're just going to finish up by comparing this column with this column under the OR operator. So anything, or this is an AND operator, sorry. Anything with 2 trues in it is true. Everything else is false. So we see this is true, 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 true. We have 1 false here, so that's false. We have another false here, so that's false. And we have 2 falses here, so that's false. Now we just see that side by side, the yellow and the green columns are identical, which means that these 2 statements are equivalent. Let's see, we got 8 minutes already. Guess I should do another one, but that did take up a whole lot of time. I'll save another one for another video if necessary, but this might be the end of the playlist. I'll see you in the next playlist.